everyone, this is PCB, your trusted PCB partner. Today we will be drawing a complete schematic in PCB. After the explanations in the previous episodes, we now have a basic understanding of the power library, footprint library, and schematic tools. So today we'll use what we've learned so far to draw a complete schematic, specifically a 4-position DIP switch controls the CD 4511 and drives the LED. Now let's open the schematic for analysis and start drawing. First of all, every circuit board needs a power input. For convenience, I plan to use a USB socket as the power input and draw power from the USB. Let's select the component USB and then choose the USB-A 2.0 type. For the package, we choose DS1095, which is a relatively common model. Click OK to place it, then press E to edit its properties and change its value to DS1095. This way, its value will be displayed in the table. Next, let's place another component, the 4511. Select it, then choose the package. If you find that it doesn't provide a default package, just place it first and press E to edit its package. Edit. We'll use CD 4511. Enter CD 4511. Select the package. When selecting the package, it opens a bit slowly, so please wait a moment. Here we'll use the SOIC 16 package, type SOIC, then select the 16P option, choose the 16P1, click OK, and now it has the package assigned. Next, let's place a 4-bit DIP switch, K160SW. Since we need a 4-bit one, let's look for it. Usually this kind of DIP4 has 4 switches inside. Let's place it. Since it's used to set high and low levels, we also need pull-down resistors. So let's select the resistor. Type R1S to select the resistor. For the package, we'll choose according to the actual situation. Here, I'll use the 0603 package. Like 0603. Then press E to modify its value. We plan to use a 1K pull-down resistor. Okay, we need to place 4 of these, but if we have to set them up again each time we select one, it's inconvenient. So let's go back to the selection tool, select it, and press Ctrl+C and Ctrl+V to copy 3 more. That will be enough. Alright, this group is done as well. The last component is the digital tube. For the digital tube, we'll use the one we drew ourselves. So in our own library, we select our library, choose the digital tube, and now all the components are ready. Next, let's add the power supply. This system uses 5 volts, so we'll place a 5 volt power source. Find the 5V power supply. Here, on the USB, there's one available, so we need one. Then let's add a ground, GND. Move it aside a bit, and then let's copy a few, because every system and every component needs one. The 4511 and the DIP switch needs one. Then add another ground. The 4511 7-segment display and resistor each need one. With power and ground set up, we can now connect them. Select the connection tool. Alright, to save time, I've already connected all the power and ground lines. Since we only have one schematic here, we'll choose the local network. Next, let's proceed to add the necessary labels for the DIP switch. These specific labels are designated as A, B, C, and D. We will commence by carefully placing the label A, then subsequently placing B, followed by C, and finally the last label, D. Then there are a few other places that need these 4 labels as well, so for convenience I'll just use copy and paste, Control C, Control V. Next, for the resistors and the 4511, connect A to the resistor and 4511's AB to the resistor and 4511's B, C to the resistor and 4511's C, and D to the resistor and 4511's D. After that, all that's left are the DIP switch, the 7-segment display, and the 4511. Since A, B, C, and D are already taken, let's use QA, QB, and QC here. First, still select the local network and input QA, QB, QC, and QD. Oh, I must sincerely apologize for that previous statement. I seem to have misspoken, or perhaps articulated my thoughts inaccurately in that particular instance. What I truly intended to convey, and what is indeed the correct and precise term we should be focusing on in this context, is quantitative easing, which is commonly and succinctly abbreviated as QE. My apologies for any confusion or misunderstanding that my earlier, less precise language may have inadvertently caused regarding this important concept. QF refers to the quality factor, which is a measure of the purity of a resonance circuit. QG, on the other hand, represents the quality grade, indicating the overall quality assessment. Then, on the 7-segment display, we also need to input these. So I'll just copy and paste again, Control C, then Control V for A, B, C, D, E, F, and G. Then you'll notice that actually DP isn't connected because CD 4511 doesn't have a drive pin for the decimal point, so we just leave it empty, and that's fine. Alright, that's all for today's content. If you enjoyed this video, please subscribe to my channel for more videos. Thank you everyone.